Hello and welcome to Scully Unclassified. I'm Scully. I've been a software developer and architect for more than 20 years, and I created this channel to develop your skills as an embedded software engineer with a focus on aerospace. Today's topic, writing good requirements and why you should bother. First off, what is a requirement? Well, a requirement is a declaration that the system must do something. A requirement is then tested to make sure the system does do it, and if you have a large, complex system, you'll often have a hierarchy of requirements. At the system level, you might have requirements for software, for hardware, and as you write your software requirements, there's often a parent requirement that you derive from. What I want to get into before talking about writing good requirements is why you should bother to write requirements. I want to stress here that having an agile approach is not a good reason to not do requirements. Of course, running software is more important than comprehensive documentation, but do want to call out that requirements themselves aren't simply documentation. They are guidance for what you need to be doing and be looking toward how you're going to test and buy them off. Also in the Agile Manifesto, it talks about customer collaboration being more important than contract negotiation. Of course, that's true. But as you collaborate with your customer, where are you capturing the results of that collaboration? Are you just having a conversation, scratching something out on a whiteboard? What's the product you're going to do? How do you know that when you collaborate with your customer, you're talking the same language, have the same understanding of correctness, unless you write that down and capture it in unambiguous language? And the best way to do that is within a requirement specification. So you need to write requirements. Where do you start? Well, you may be lucky enough to get a organized and well-defined system requirement specification. So now you have higher level requirements that, from a software point of view, you need to derive from those, and requirements that the software needs to do something to support those higher level system functions. You could also try brainstorming, but much like a regular storm, it can be chaotic and can be hard to know whether you've covered everything. My preferred method of creating requirements is writing those requirements to your use cases. You can click the banner above to see my video on writing use cases. And give a quick summary here. A use case defines actors or external entities. And a use case is a series of interactions and steps to achieve a goal. So if you have a good use case, you've identified all the external things you're talking to, you have a goal in mind, and you also have what steps and interactions are needed to achieve that goal, and that makes the perfect starting point for writing the requirements of what your system needs to do to achieve the goal you talked about in your use cases. A requirement specification is like a contract, and because of that, requirements definitions have very specific language and legalese that you need to follow. As I mentioned before, requirement's a declaration that a system must do something. So for any requirement, the subject of the sentence needs to be the system you're writing that requirement for. The spacecraft, the flight software, any of the systems that are on the spacecraft. It's what your scope is of your use case and should be the subject of the sentence within your requirement. The verbs in the requirement are very specific, and you only have a few choices to choose from. The most common one are shall statements, like old biblical language, thou shall. The spaceship shall, the flight software shall. You may have requirements that are will statements, and those are usually things that are statements of fact. The missile will be in a missile launcher. Give you some background, but they're not things that you're testing the system for. They're not a shall statement that it shall or must do something. You'll find other requirements that have should statements, that the spacecraft should do something, and that's not as strong as a shall statement. It's not something that the system is required to prove that it does, but it is a design goal or a goal of the system that it should do something, and if you can get that in, that would be all the better, but it's not something that the system must do. Following the noun and the verb, spacecraft shall is a thing that it shall do, that's required to do. Spacecraft shall send telemetry. You do have to worry about in your requirements what external interfaces you're talking to. And if you're going from a use case, you've already broken that down. A use case is interactions and steps that you take. So as you're looking at your use case and writing your requirements, you've already identified those external systems. The spacecraft shall send telemetry to a ground system. Following that use cases as a guide, now you have what you're doing to the external of your system. And if you have requirements that have no effect outside of the subject of your sentence, you should ask yourself, do you really need those at all? If the software is calculating a value and it doesn't play in any external communication or sharing with any external system, then is that really necessary? Requirements often have references to other more detailed documents. So the spaceship shall send telemetry to the ground system in accordance with a telemetry interface document. So that document can be controlled separately, but you are required and you must follow it to be able to meet that requirement. You should think about what triggers your requirements, and using a use case helps with this too. The spacecraft shall send a status report upon receipt of a status request from the ground system. So there you have your noun of the spaceship. It shall, must do something, send a status report, and that status report, you don't want to continually send it, obviously, so it's triggered by a particular interaction with an external entity. So on your use case, you might have a receipt of a request and sending of a report, and that'll give you the requirement that the spacecraft shall send a status report upon receipt of a status request. In addition to triggers, it helps organize requirements by the state or mode the system is in. So for example, the spacecraft shall send a health and status report upon receipt of a health and status request from the ground system while in launch mode. Requirements also capture the numeric constraints of the system, like how fast it needs to respond to something or a certain number or boundary that it needs to meet. So for example, the spacecraft shall send a status report upon receipt of a status request within 100 milliseconds. The spacecraft shall produce a gazillion pounds of thrust. All those numbers are important for your testing and also to really understand and communicate the capabilities of the system. In addition to these functional requirements, things that the system does, whether it's in a certain mode or certain trigger, you will have some often non-functional requirements. These are often constraints on the design. So for example, you could have a requirement that says the flight software shall use no more than 50% of the RAM. It's not actually something that the software does or is programmed to do, but it's a constraint on the software and is really a non-functional requirement. You'll see some of those also that go to even the calculations that are happening inside. For something that might be considered a implementation detail, they're important to meet the requirements of the system and how they interact with others. For example, the software shall use WGS84 for its ellipsoid during its navigation. Not an interaction on the outside, but an important design constraint as we move the system. So let's talk about bad requirements. Bad requirements primarily are ones you can't verify. So as you're writing requirements, the first thing you should be thinking of is how you're going to verify that. If you have a requirement that the spaceship shall do something, you should be thinking about what kind of test you'd verify that it does actually do that thing. You'll have language of shall be capable of or shall support. You should be really worried about verifying that requirement. Bad requirements are also overly prescriptive. You might know that there's a computer inside the spaceship, but you shouldn't be calling out the internal architecture or the internal things that the subject of your requirement is, and shouldn't be prescriptive about how it does something. The requirements should be really focused on what it should do. You should also be paying attention to the subject of your sentence for each of your requirements. It should be the scope of your use case or the scope of your requirement specification itself. So if your sentences are not starting with the same subject for every sentence, you should again get worried. You should also not put requirements on your external pieces. So for example, if you've got a requirement that says the user shall press a button, you can't put requirements on your user. It should be really the system or the software shall do something upon the user then doing something. You should also not have requirements that are vague, like the user interface shall be easy to use. How do you verify that? What you can do for something like that is say the user interface shall conform to this set of guidelines. And that's something you can verify. You can bring up the user interface and show how it conforms to those guidelines. You should also be really leery of requirements with ands and ors. They can become very hard to verify, especially not only upon your triggers, but what it shall do or what situations they are. should really think about how you could break those down and try not to have the ands and or statements within the requirement. Another bad requirement are negative requirements. It's really hard to verify that something does not do something. So if you have requirements that say the system shall not whatever, how are you going to verify that it does not do that? So if you can avoid negative requirements. Good requirements are ones you can verify. So let's talk about your options of how you verify requirements. And as you write them, you should be marking what your verification method is. How you can actually verify that that requirement is met. And your options are test, analysis, demonstration, and inspection. Most of your requirements should be verified by test. The system shall do something. You write a test that shows that it does, and you can verify that requirement is met by your piece of software. Some requirements require analysis, so that might even be over multiple runs. So if you're thinking about a missile system, you might have a number of runs, each one with slightly varying degrees of how hot the rocket motor burns or how much the wind is blowing. And you create a large amount of data, you get subject matter experts to perform analysis, and those requirements then are verified by the analysis of those larger sets of data. Demonstrations are ones that you can't quite test. Demonstration's pretty popular for user interfaces. So it may not be able to have a specific test for a user interface, but you can demonstrate by running it and showing that it does do it, but less formal than a test with expected results and comparison for that test. And finally, you can verify requirements by inspection. And this is not very satisfying. Your number of inspection requirements should be pretty low. But if you have design constraints, like your software shall, or the flight software shall use WGS84 in its navigation calculations, that's a good candidate for a requirement that's verified by inspection. Now, as you add up your requirements and you see how many are test, how many are analysis, how many are demonstration, how many inspection, vast majority should be test requirements. You should try to verify as many requirements as you can by test. And if you have requirements that are difficult to verify by test, you should have a good grip on that. Are they good requirements, or are they something that really meets the analysis, demonstration, or inspection point of view? In closing, a requirement is a declaration that the system must do something. Requirements have specific verbs. A shall statement is something that the system must do and must be verified. A will statement is a statement of fact, and a should statement is something that it should do, but you're not obliged to do it. Requirements are verified. Preferably, you verify them through test, but you can also verify requirements through analysis, demonstration, and inspection. I appreciate all your time, and I'd love to hear everyone in the comments, any subjects you'd like to cover next, feedback or questions, and thanks for watching.